Good evening, everyone. Today we continue our discussion of blockchain cryptocurrency. So last session I couldn't make a session. Also, I decided not to publish it online because the next session is about coding. So I think it's better to have it in person. I'm going to send you an online session for a non-coding materials that you can just watch the video later, but I owe you one online session. Okay, before doing that, so we have these are fourth and fifth sections. For each section, please go to materials, and especially for section 4 or part 4, we have 5 new Python files. Just find the location that you save your PyCharm project. For example, when I open my PyCharm, look at the address I have here. It said user ID $documents crypto project. So C documents crypto project. So what you do from your Moodle, download these new 5 Python files, and please paste them or put in your crypto project location. Again, your crypto project location address is on the project section of your PyCharm. I'll give you a few minutes for doing that because otherwise it's very hard to follow my instruction for today. So when you copy and paste those Python files in your project, you would see in your PyCharm project automatically. Look, I have so many new files. It should be something similar in your computer. Yes. Lights. I have some buttons here. So today, in my office, I had a very good discussion with Narayan. So he wanted to know the big picture, which I think many of you might be also interested. So let's talk what is the big picture, what we are doing. So we're going to talk about hash function and initial of blocks and what is in each block. Let's send the project here up because I can use the main board. So oh. Okay, so yeah, I do. Oh my, maybe it's a little hard for me to display off. Okay, that's it. Okay, let's talk about the big picture. So we know that we have some blocks each plug has some sections. One is transaction data. Previous hash. And also nuts. And last but not least, it's hash. So that is same for the next block. It also takes hash of the previous block here. Transactions. So again, we know that there is a hash function that whatever you put in, the output will be 256 bytes of different characters. And mining just means having a hash that is a certain number of zeros. So it's like 3 zeros, this is 1, 2, say 8, 1, 0. So a computer, some computers try to find a number that you add to this information, end up having a hash that starts with this number of zeros. I mean, here is with 3 zeros. And again, we know that we cannot, we can, but let's say if you change some transactions here or hash them, this hash will change because it's another character of hash. If this hash change, since it's an input for the next block, this block also change. The hash of this block will change. And if the hash of this block also change, the next block hash will be changed. So there is a, it's how they chain to each other. But this is just a chain. But generally speaking, we have some miners. So what they do, they take these 3 blocks, all of them has a copy of it. Okay. Now, let's say Dr. Han, who might have 100 Bitcoins in her wallet, so she has a wallet. She wants to send, let's say, wallet of Naraya. She wants to send them 2 Bitcoins. So Naraya wallet N, Dr. Han wallet DR. So what happens if there will be a transaction to this wallet to this wallet? All of the miners would hunt all the transactions that they can, including this one. Let's say this transaction would be cut in next block. Next block. And maybe not this in green ones. So I still so it's not in these two versions of the block, but in these two versions. Again, these miners hunt for new transactions. Maybe at this time, maybe this transaction, this mine can find the transaction, also this mine. In these two versions of chain, just one of the block has the transaction. So let's just show it with both of the wallets are. Just keep working. So let's say this mine is so strong that they can just mine so many blocks much faster than the others. This would be the longest chain. So the transaction between Dr. Han and Narayan won't be confirmed, but they are not in the longest chain. If they are, maybe they can wait for 3 to 6 confirmation. So usually after 6 confirmation, it doesn't. I mean, no miner can make a longer chain, so it will be confirmed. So, have you guys ever tried to send some cryptocurrency from one exchange company to another one, like using Binance or Coinbase.com? So if you try, first of all, it might take a little bit. It doesn't send immediately. And sometimes you check the web page, you say convert confirmation number 1, confirmation number 2, number 3. It's just the exchange company is just waiting for several confirmations to just finally verify your transaction. So it might be one of the reasons. One of the sessions talk about the exchange company that have the same coins, but again, it's one of the reasons. By the way, generally speaking, even the wallet is a kind of a server. Miner is a server. This one is a server. So they make some connections. TCP/IP. They use TCP/IP and basically send information to each other. These nodes have the complete copy of all the chains, but the wallet just have the blockades. So if you have a wallet, you don't have to download all of the blockchain. Just the block header is enough. At least up to this version, might be another update that maybe some part of the chain will be enough for the wallet. But the miners have they have the complete copy of the whole of the blockchain. Okay, so having said that, previous class we talked about hash functions, checking the validity of transactions. Basically, you should have negative transactions in everything out, and also the previous hash, which is recorded here, should be equal to the calculation of hash in here. Because basically, it's how it's created and how we check the chain is still secure. So today we learn more about this transaction and how this concept works. Hopefully, if we have time, we will talk about miners, how to find the longest chain, basically how to communicate between wallets and the miners. So, okay, it takes a little bit of time. It's telling me the system is shutting down, so it might take a little bit to come back. Hopefully by now, you could be able to go to part 4 and copy all of the Python files from here into your cryptocurrency project. Okay, so let's go start section. Let's just review a little bit. So this is generally speaking of leading zeros probability or the problem. So if your hash should have just one leading zero, means out of 256 possibility, just one of them, two leading zero, 25, 256 times 256, and just lead two leading zeros, just do the multiplication. Another thing, we have floating point error in Python. Please do it on your system. So just open any Python interpreter. So type 0.02 plus 0.04. Look. So, or do this comparison. 0.02 plus 0.04 equal 0.06. False. So we might have this issue in cryptocurrency too. So this is some internal algorithms of Python and any computer calculations, which I'm not very aware of that. But having leading zero error might cause some issues. So when we want to do a comparison between two numbers that they are not integers, usually we don't compare equality. Like here, I'm comparing instead of saying a plus b equals c, I'm just saying that a plus b minus c more than a very small number. So that 0.000 whatever one is a very small number. So if difference is more than that small number, I would say they are different. So if it's less than that, I would consider as a floating number error. Having said that, you would see this comparison in the codes that I'm showing to you, but I just wanted to give you a heads up why I have such a thing. Why you have a small number, and instead of comparing equality, I'm comparing differences if it's different from a very small number or not. Okay, these are the functions that we reviewed in the previous class. First one was signature underline basics. Basically, with this file, we created public and private keys, and we verified a message that was signed with a private key with another public key. It was the goal of this function. We had another file. We had another Python file, blockchain underline basic one. So basically, this is just a general blockchain. And instead of just comparing everything, we just focus on comparing the hash function. And basically, the right side is the recorded hash that we put in the blockchain. On the left side is the hash function that we calculate. So as you see, self.previous block means the information of the previous block, and dot hash function means we apply hash function on the per stack. So it just helps us to kind of security countermeasure. So if somebody hacked the Paris block, the new calculated hash is different from the one that you already recorded. The last file that we reviewed the previous class, it was transactions underline basic one. So basically, it just for adding inputs, outputs, signatures, signing the messages, and validate if a transaction correct. So it was some if conditions like we should have positive crypto amount. So total in should be less than total out because some part would go to miners usually. So you do some fees. So the amount that you put in. Sorry, I made a mistake. So total out should be less than total in because some part of your incoming cryptos would send to the miners. And also we check the signatures in this file too. So I'm not sure if you have issues with these files. If you want, I can go inside of each and just open up on my development environment and just go through that. So you guys want me to just okay, so today coding part has two sections. First, how to save a ledger. So ledger just means the book of transactions. So basically, I did some updates on the codes. For example, the first one, I used just typo. Serialization, not sterilization. I just did some formatting, the type of formatting serialization. Basically, you prepare your data to be read through some saving function. Also, since the signature is changed, I import that file in the second file, which is transaction basis. I update this file too, and also I'm introducing a new file, which is TX underline blockchain basics. It basically is an update on the previous blockchain file. This one has transactions and blockchain together. So basically, it's a blockchain that is specified or specialized for keeping record of transactions and checking validity of our transactions. Okay, so having said that, okay, so let me just open my PyCharm. I close the extra ones. So let me open the signature basic too. So as you see, this time I import serialization. It's just basically for saving the transactions. In Python, we call them pickling. So pickling just means saving your data. As you see, when I do generate the public and private keys, this time I just call serialization. Basically, just a formatting function. What I mean formatting, so we don't do that much of math. We just format one type of data to another format, so you can use in another Python package. So sign is same. Still, we sign a message, which our transaction with the private key. At this time, so when we want to verify, we verify with the serialized public key. And again, let me just run this file. So again, for run this file, right click, run signature basics 2. So let's just check one by one. So after name equal main, it just means if I'm calling this file as if I want to run this file, the codes after this line would be run. If I import it as something similar, a package to another file, you don't see calculations after name equal main. So anyway, first line, I'm creating a public and private key. And with the print, I'm just printing both of them. So you can see the general shape of private and public key. So this is my private key after print, and this is the public key. Then my message was, please come to Booster. And I signed this message with my private key. And also I print out the shape of my signature in the hexadecimal format. So it's the reason you see such a very long line. So this is the signature. Then as you see, I'm verifying the message that is has the signature 1 with the public key 1. So again, it should be correct because the signature is from private key 1. Now I'm verified with the public key 1. So as you see, the next print is the result of verification is true. So you see the result here. Again, I make a new private public key. I sign the message with the private key. But this time, when I want to verify it, I'm verifying with the public key 1. The signature 2 was signed with the private key 2, but I want to verify with the public key 1. So it's the reason you see such an error message. So sorry, the if condition is false, so the second line would be run success. The spam message is disregarded. Again, this verification was false. So after if, the second line would be run. It's the reason you see this print at the bottom. In the next verification, I'm changing the message. I'm adding in the United Kingdom to the message, which was, I think, go to the Worcester. So message is changed, but private and public keys are correct, but still, since this signature is for different message, when you want to verify, you get false. So just as a quick note here, similarly, let's say instead of message of saying that go to Booster or United Kingdom, whatever, it was a transaction, and it was somebody sending some Bitcoin to someone. If you change the sender and receiver, when you want to verify it, you get an error. Because the result of the verification would be false. Questions? Okay, so if there's no question, let me open the next one. So in this one, I'm just taking care of transactions within a block. So again, if you consider the big picture, so you sign a message, you put in the transaction, and you put the transaction into blockchain. Okay, let's open that file, which was transactions basic 2. So as you see, it has 4 sections: input, outputs. So the monies that come to a transaction, the monies goes out of the transaction. Signatures. So the way that I designed this blockchain, whatever who that put money into a transaction should sign. On top of that, sometimes you want a third person also verify a transaction. So I added extra section for transaction requires signatures for somebody on top of the sender and receiver who might need to verify the transactions. So for each, I have a function. So for adding input, adding output, adding requires signatures, and also the people who might need it to sign as a third party. So the validation here is starts here. So I have a method inside the class of crypto transaction of crypto TX. So first, it just collects all of the data that I have in my transactions. So this includes signatures, input and output transactions. And first, it just checks the signatures to see if it can verify a message with the signatures are in there. Then it counts total input and total output, because it goes through input transactions. It sums up all of the input transactions, same for output. So here there is an if condition. So if total output is more than total inputs, it gives false. It shouldn't be that. Total output should be always less than total input. Also, I'm using a representative method. So it just means I can have a string for a Python class. It just shows me some general information about my class. For example, as you see here, I make a simple string of $, then I want to put inputs, I want to put outputs, the addresses, and also the signatures. So again, this part of the class would make a string as a representative of that class. So whenever I call that class, this string gives me some general information about the class. I give you about 5 minutes if you want to put some comments on the codes or have questions from me. Then I go to the next part. Okay, so let's what happened at the bottom of this file. So as you see, I generated 5 public and private keys. These are basically you can consider the wallet that we said. Look at the first transaction. I'm adding 1.5 from public key 1. Public key 3 also add 0.5. And 1.4 of that coins, that another coin would go to the public key 2 and 0.6 to the public key 4. Also, key number 5 is a witness of this transaction. He or she need to check the transaction. So as you see, number 1 and 3, since they put money into the transaction, I add their signatures here, and also number 5 is the third party. So the transaction should be correct. We don't have any issue. So everybody who needs to sign already signed, and also total output is equal to total input, or total input is not less than total output. I also create the second transaction in this one. Public key 1 at 2 coins, and number 2 and 3 takes 1 coin. So again, total in and out are equal, and also we get the signature from the first key, because who put the money into the transaction should sign. Again, this is my own constraint. If you want to play with the code, maybe you remove it. Maybe you would say, I also want to check signature of people who takes outputs. But here, I just said I want to see the signature of third parties and also the people who put money into the transaction. Again, you have flexibility of changing those constants. And number 3, this time output is less than input, which is fine, because in some cases you might pay some fees, so your output could be less than your input. Okay, so let's run this file. Again, within PyCharm, right-click and select Run Transactions Basic 2. So look at these 3: success transaction, valid, valid, valid. So these are this loop for transaction 1, 2, 3, and it just runs validation. If they are valid, it prints success, the transaction is valid. Again, there is no issue there. So we output is less than input, and also we took all the required signature. Okay. Look at the next transaction. This time, input is 5, output is 5. But we took signature of private key 2, which is not correct, because our constraint was whom put the input money should sign. So this transaction is not correct. What about the next one? So input is 5.3, output is 5.2, and also the third party as an arbitrator should sign it, which is key 4. But we said key 3 should we take instead of taking signature of the arbitrator, which is number 4, we took the signature of number 3. So this is a bad transaction too. The next one, public key 3 and 4 put $7 and $6, and we took 13. But when we wanted to take signatures, we just took signature of key 3. Key 4 is missed. So again, this is a wrong transaction. So it's the reason at the bottom when I did the for loop on these transactions, you see the problematic, because these are the problems that I'm finding here. Look at here. Total input is 3 plus 2, 5, but the output is 6. So output is more than input. So this is again invalid transaction. The next transaction has negative values. Again, doesn't make sense to have negative coins in a transaction. So this transaction would be wrong too. In the last one, 9, so as you see, input is 3, output is, input is 4, output is 3. And also since number 4, key 1 put money in the transaction, we also took the signature from key 1. But look, after signing, there is a hack. So the output is changed from key 2 to key 3. This is somebody hacked the transaction and wants to take 1 coin from transaction. This time, since the message is changed, when you do verification, it doesn't comply with the private key who signed the transaction, so you get an error. So now I did a loop over all the transactions. All of them was not correct. So you're getting second part, which is a problematic transaction is identified. Also look at the last line, print REPR or repre, representative of transaction 1. Again, this is the representative method of my class. So it shows input, output, the signatures and addresses. So when I run REPR of transaction 1, it shows me input, output, the addresses, the signatures. So it's the reason at the bottom of the result, you see transaction 1 for 1.5 from this coin, 0.5 from this public key. For the outputs, 1.4 from this address, 0.6 from this address. It's the signature of the required person, and this is all the signatures that are taken. Again, representative method is optional for me because I wanted to do several checking on my side. So I always want to have a representative method which just shows me what is going on in my Python class. Okay, the new file is text blockchain basics one. Basically, in this one, I consolidate the transaction with the blockchain file. So it's a blockchain with the transaction information inside. So the previous blockchain file that I had here, it's just you could put everything there. It could be simple messages. You just check for the hash function. But the newer one, which is TX blockchain basics one is basically has transaction information inside the blockchain. So when I want to do validation, it does two things. First, it checks if the transactions inside the blockchain is correct, which we didn't previously. So we check if it's negative, input is more than output, and also everybody signs it. The recorded person signs it. On top of that, this file checks if the previous hash that you record right now is equal to the new calculations of hash. So it has good of both worlds. Sorry. Okay, let me just show it to you guys. So it has the first method is block add transactions. It just add transactions into my block, and I'm not sure if how you're familiar with the Python, but look at the new class that I have here, block with TX. The input is block. Let me show it here. So I already created a block class. It's just I use it for checking if the hash of the blocks are changed or not. The previous hash equals the new calculations of hash. So this class, which I already defined in blockchain basic one, now is the input for a new class. So it just means that new class inherits all the characteristics of the block class. So look at here. This method has two validation sections. The first, if it just takes the transactions information and wants to see if there is no negative transaction, input more than output, and everybody signs it. The second part, it check if for this validation, okay, sorry, the first one is for hashing. So this validation has two sections. The first section checks if the recorded hash equal to the new calculation of hash. The second one is TX, or from transactions, just checks no negative transaction and input more than output, and everybody signs. Again, if you look at here, let me just show it to you. So TX. So look here, I defined three public and private keys. I've defined the transactions, and these transactions has one input, one output. It checks validation, and also I'm signing it here. But look, now I'm recording that one of the public keys. I'm with the open public key.dat. I'm opening this file. I'm dumping the public key here. I close the file, and again, I open back that file. So I make a file for transactions. I save and close it. Then, with the load method, I can import the basically the public key that I recorded. So this tx.dat or that is just similar to a ledger function. A ledger in the Bitcoin, which you can take it because of all the transactions and just save it somewhere and load it back for your validation or for mining. So again, pickling or pickle pickle package is just for saving and loading the files from or to Python. So look, I'm making a root block. So root block is, or Genesis block is the first block of the blockchain. So when I call this class, the first block is none, and I'm adding the first transaction to the block at txt to my Genesis. I made the second transaction, 1.1 input, 1 output, added to the txt2, and also that transaction is added to the root block. I just repeat the process. So we have the second transaction, and now I'm making new block. This block Okay, in the next class, again, go back to the codes. Some of the codes that we will use for the next class. But just as a brief, what you might see in the future of the blockchain design. So how to communicate between miners and wallets. So there is some internet protocols that it doesn't go to the next page. So it seems no. So whenever you want to communicate with the server, like clark.edu, your PC, laptop, or cell phone would communicate with your router and the router to the university server. So all of the communications through these codes that you see, even the website has its own IP configuration. So whenever you request a connection to a server, it just knows that after getting your router, it should shoot out to your laptop IP address. So these are the kind of topics that we are going to cover. Also, on top of that, even on your laptop, you might use different apps like Chrome, Telegram. So as you see, all of them has the same IP address, but they have different ports. So each software on your laptop has its own port. What are the issues that you might face? Sometimes some of your ports are used by another application, so we cannot do communication. Sometimes it happens. So basically, we will get familiar with the TCP/IP. So this TCP part handles how to make packages of the data. So let's say you want to receive a video, or you want to upload some picture. So those files would be divided into some certain packages. So the packages part is made through TCP, and IP just takes care of the routing. So routing from your PC to your system. So these are some general terms. So socket is the information required for communication between the computer server tasks. So a server such as Clark first it creates a socket, which has the information for the connection. You bind socket to an IP address and port number. Set the server socket to the listen mode. So it just means that certain socket just wait for your laptop to communicate with the server. Then accept the client connection. So this is the connection that comes from the laptop, and then just send and receive the data from your laptop to the, let's say, Clark University server. So basically, both of them make a socket, and that those sockets just will be used for communication. Client, it just create the socket and make a connection, and then send and receive the data. So we're using some Python packages on the protocol. You don't have to do everything in scratch, but just keep in mind the socket part is the important section. So just basically, if I oversimplify it, this is just a fancy name for saying that I want to connect my laptop to the Clark University server. So the reason I'm using socket term, because later on, when in Python, there will be some code for me creating socket. Socket in Python just means making connection from your laptop to another server. I think Dr. Han won't like my very uneducated terms. I just trying to oversimplify it. So this is basically what happens between a mining node and a wallet node. So wallet and miner, both of them has the blockchain copy. So wallet send transactions, the miner takes the transactions and try to find the nonce and basically create the block. And after the block is created, the 9 blocks will be sent to the wallet, and also will be added to the blockchain information that wallet has. So basically, your wallet and the miner, both of them are servers, but your wallet is much simpler, sick one in comparison with the miner server. So basically, 2 servers that communicate with each other. Questions? I know it was a very complicated topics for today. And frankly speaking, I show you like 400 lines of code in just less than 1 hour. So I never expect anyone to fully understand it. I just want you guys to get an overall picture in case. And frankly speaking, this course was different. First, it's designed for blockchain design. Now it's for blockchain understanding. So I just want you guys to understand what is going on as a big picture. If you're interested, if you want to be work in a blockchain company, which sometimes the pay is really good. If you're a blockchain developer, you can expect about 200K as your salary. But if you're interested, you can set office hours with me, and I just go to each code line by line. But I don't expect me to summarize 400 lines of code in just 1 hour. It's overcomplicated. I just try to say, okay, this section of code does this section does this section does this. By the way, the Bitcoin code, the script it's not Turing complete. It just means there is no for loop in the Bitcoin blockchain. But in the blockchain design, there is some for loops or some while loop. So also there's another difference between Ethereum and Bitcoin. Although Bitcoin is developed by C++, there is no full loop in it, but there is some loop in Ethereum. And there is some loops in my blockchain code that I'm designing for you guys. Okay. This is one application of hash function. So let's say I give you multiple choice problem, and I only give you the full grade if you answer all of them correctly. So instead of basically, I mean, there is an easier way, but I just get your answer. I calculate the hash, and I compare with the correct hash. So if you answer all the questions correctly, the hash should be same as the hash that I have for all correct answers. Also, if you Google it, I wanted to give you an assignment, but I think it might be too much. But you can just Google to see the other application of this hash function. But one of them is just for grading. So instead of checking all of the questions, I make an Excel file of all of your answers. I make its hash function. The hash function is a one line. I compare the hash function of your answers with the correct one and just say, if you get 100%. Okay, again, we talk about mining and basically the mining process in general, but again, every time that you ask me the question, every time I find different answers. One answer is just incentivizing a decentralized center. So they try to simulate gold mining through a blockchain. So, and instead, the Bitcoin mining may not be the best or not the most innovative one. Some people try to simulate those gold mining or try to find different ways of incentivizing people for mining. But Bitcoin was the first one. So this is our option reading, the ideas that lead to the Bitcoin. So Markup tree, hash functions, Bitcoin. So as you see, there is several, Bitcoin blockchain technology started to develop mainly from 1980s, and basically Satoshi Nakamoto, he just tried to basically merge all of the goods of how to do communication, how to do cryptography, and he tried to find a way to simulate mining, gold mining, as a way to maintain the blockchain. So this is one of your assignments. Please just Google and try to guess who is Nakamoto, Satoshi Nakamoto. There is different ideas about the guy. So sometimes, even I've read one article, they said US NSA is the Satoshi Nakamoto. So the people are not sure who is the actual one. So I don't judge about who your candidate. I just want to see your thought process. So try to do your own research, try to guess who could be Satoshi Nakamoto. Okay, so let's talk about the smart contract. The smart contract, according to Nick Szabo, is a smart contract is a set of promises specifying the digital form, including protocols with which parties perform on these promises. Also, some people think Nick could be Satoshi Nakamoto anyway. But just keep in mind, although it's a decentralized promises, we still have government. How? I mean, you get rid of some part of the government who's take control of the money, maybe, but still you need to follow your government regulations. One of them, for example, the most obvious one, you cannot use cryptocurrency to buy drugs. So still, there is some role of the government. So smart contract was minted by different people at the same time, but the most influential one, which is the main developer of Ethereum, is Vitalik. So this guy invented Ethereum when he was 19 years old, and I think he was a computer science student somewhere in Canada. So in this video, he explained about the Ethereum and smart contracts and how the general ideas about this cryptocurrency blockchain. By the way, first, I think his first task was in Bitcoin was writing articles. So he used to write articles about Bitcoin and get rewarded by Bitcoin. I think when he was 17, 18 years old, then when he exposed more into computer science, he said, now I can make a better one. So he made his own cryptocurrency, and now he's a billionaire. I think he's just maybe 30, 31 years old, and he's a billionaire right now. So sometimes I envy him because some concept of blockchain is still difficult for me to understand. But when he was 19 years old, he made a platform. So basically, he's just saying he pointed some differences between Ethereum blockchain, which is a smart contract-based blockchain, Bitcoin, which is a programmable and you can make some applications on top of the Ethereum blockchain. So these are some main differences. So as you see, the Genesis block, which is the first block of Ethereum, was 2015, or maybe about 6 years after Bitcoin. So about the fees is required, you should have some fee, they call it gas fee, which in Bitcoin is voluntary, and basically add fee in the Bitcoin to incentivize your transaction. The hash function is ETH hash for Bitcoin SHA-256. Most of them asymmetric, proof of work. So basically, both of them proof of work, but Ethereum is trying to move to proof of stake. Some people believe it has some part of proof of stake and some of proof of work. The next line is typo, so let me just change it. Ethereum has proof of stake. The other difference is Bitcoin is a transaction based, so you have the concept of transaction in output. As you see, we don't record any balance, so whatever comes in should go out either to receivers or the miners. More interestingly, Ethereum has a pre-sale. These are other smart contracts. So Ethereum Classic was a hard fork of Ethereum. Happened in 2016, EOS 2018, Solana 2020, which somebody made really good money. Otto Cardano was the Genesis block was 2017, and actually the founder of Otto Cardano was a co-developer with the Ethereum. I think he was a computer scientist who helped Vitalik to create Ethereum. Then he just moved to a new project, which is Otto. Also, new is people sometimes call it the Chinese Ethereum. Basically, the co-developers are Chinese, and it's actually one of the best ones. So based on the Chamber of Digital Commerce in the United States, these are use cases of applications of smart contracts. As Vitalik said, on top of the smart contract, you might have several applications like supply chain, mortgages, finance, insurance, trials, trade, so on and so forth. However, if you check this website, a state of dApps or dApps stands for decentralized application. You can see different categories of smart contracts. Basically, these are the applications that people develop on top of smart contract-based blockchains. So let's go there. So there's a lot of room for innovations and be entrepreneur. So have you guys ever heard of Upland, OSIS, or these are NFT platforms? But on the category, let me just expand it. So these are all categories, all the applications that people develop over smart contracts. So games, gambling, social media, finance, exchanges, decentralized finance or DeFi, NFT, energy, health, insurance, and storage. On top of that, you can see the activity of each project, different platforms. So let me just check Ethereum for now. Decentraland. These are some of the most famous NFT projects. So more specifically, if you're in some certain industries, let's say if you're in the healthcare, maybe you can see what people are doing through the healthcare. So let me just change all. Or let's say you're working insurance company. You can see the applications that people make over smart contracts, and it might some of them especially I look at some DeFi ones. There is some very innovative projects that I think there's a lot of room for innovations and entrepreneurship. Anyway, this is one of the good resources, state of the apps.com. So you can find the newest projects in this domain. Questions? So usually smart contracts come with initial smart offering or ICO. Those basically they sell some of the tokens to the public. Usually for supporting the initial run, so sometimes they need some money to buy software, hire people, so they make some public offerings, so people just buy those tokens. So some interesting, some of them even have the open source codes, but they're centralized. So let's say if you want to be a developer or miner, some of them even won't let you to be a part of their community. So just keep in mind, if there is an ICO, if there is a blockchain cryptocurrency, doesn't mean they are fully decentralized. Sometimes it causes some price drop, so people won't trust them that much because would say they block the codes, you cannot join. It just seems some people just trying to sell some coins and you don't have any power on top of that. So just keep in mind, not all the projects are good. But more interesting, recently people I've seen that people have FOMO issue or FOMO issue. You guys know what does it mean? Especially in the cryptocurrency, I mean, what does FOMO mean?
You're missing out, so like you do something like proactively.
Yes, exactly. So if I want simplify it, what Ethan said. So let's say I'm telling you like an example, like Shiba coin. So first, the value of Shiba coin was 0.00001. Okay, even I think less than that. So some people just bought it, and it was so many advertising over social media, and people talk about that too much. So then it priced 100 times more, 0.001, something like that. I'm just trying to give you the whole story. So some people like me, you, or Ethan, Shibu, will say, "Oh my God! If we invested maybe 1 week ago, our money would be 100 times more, right?" But you fear your fear now is if you don't invest right now, maybe you lose the opportunity. You're missing out the opportunity. So you jump into investment, and maybe you say, "Yeah, even if it lose one more zero, my money would be 10 times more." But what happens, which I've seen several times, maybe it would go back, but your money get 10 times cheaper. So it happens a lot in cryptocurrency. So I knew somebody went to hospital, and I told the example of a guy who bankrupt and had a moving job in the weekends to just compensate his loss. So have you guys heard of HODL? Do you know what HODL?
Yeah, it's like that, like hold on this.
Yeah.
Like, it's the idea of like holding.
Exactly. So let's say now it loses 1-0. So everybody would say HODL, HODL. So if you go to coinmarket.com. There's a section for social media of each coin. Would say so many people would shout that please keep money, keep money. If you don't keep your money and sell it, the price go back. So everybody would say hodl, hodl, just means hold forever. Don't try to have the community of the basically people who have their coin. So do you guys remember what happened to ICP? It was so, 2 years ago, very good computer scientists joined this project, and everybody would say would revolutionize the whole internet industry. And there was so many advertisements at that time. And I was lucky that even I haven't noticed them. So although it was a really good project, so in the first day it reached to $600. In the second day it moved to 160. Now it's less than $7. So this is an example of very good sophisticated project that didn't have a very good business plan. So I'll tell you what happened. So in the initial coin offering, the price reached to 600, but in the first public sale, they sold the coins for about 2 cents. The first private sale, they sold it for 63 cents, and second private sale for even the latest airdrop, they sold it for $15. So it was all before this 600, before when the first coin offering happened. So in the first day, people said, okay, I bought it like 1 million and each was 0.035. My money got like 1,800 times more. So let's just sell it and say goodbye. So in the first day, when all the people saw that it reached 600, they said, okay, I'm done. My money got 1,000 times more. What's the point of them keeping it? So, and there is no blame to them. So they are businessmen or businesswomen. They said, okay, so my money got 1,000 times more than what I have. Even if they invested $1,000, now it's $1 million. So let's just sell it. And since it was so many advertisements at the beginning, people believed that. I remember I have so many friends that blame you. Why you don't invest in this revolutionary coin and it would be the future of everything? So I was lucky I haven't invested, but I have so many friends, unfortunate friends that lost a lot of money. So just look, it's about 100 times cheaper than what they invested. And the interesting, if you look at the website, CoinMarketCap, this is really, they have very good computer scientists. They have a very big team. But on top of this very bad business plan that they have, also this day, which was first day of public offering, which was part of the market also crashed too. So it added on top of that. But it was some fundamental issue too. Although it was advertised as a very good decentralized project, if you wanted to check their codes, you couldn't see. Also, you couldn't participate. It was like a very closed system. So people just, so many computer scientists like Dr. Han, look at their plans. No, it doesn't seem that much of value. Everything's closed. How you can trust them? So, as I said, so I think in just maybe less than a week, it just went from 600 to like less than 100. So recently, more coins, for avoiding the first issue, which was people who sold a lot of money, now there is a locking period. So in newer coins, when you invest before public offering, they would tell you cannot sell your coin name for 6 months or 1 year. So you won't give a big shock to the market by selling too many coins at the first day. So I think there's other term for locking period, but basically when there is a coin comes in the market, if you buy it now, usually you cannot sell it right away. They ask you to keep it or hold it for a certain period of time. So, as I said, there's several new blockchain technologies, cryptocurrencies. So, but why we have so many different smart contract-based blockchain? Why Ethereum is not enough? So Vitalik answered in this way. He said there is a trilemma of decentralization, scalability, and security. He said the best blockchain usually answers two of these three. He said there is no good blockchain who can answer all of them. Maybe Bitcoin has a lot of focus on security, but it's a very slow platform. And it's very good decentralized. So Bitcoin has these two. There is a very decentralized security. You might find other blockchains that's other two, or maybe they have a security and scalability, but they are not that much decentralized. For example, ICP is still a very fast cryptocurrency, but it's not that much decentralized. You can has high security and high scalability. So he's not an academician, but since he's a big developer and he's the first one who developed the smart contract-based blockchain, whatever article he writes is like a scientific paper. Everybody look at that and try to decipher it. So it's one of his most important lectures that's cited. Also, just keep in mind, as I said, some coins are not that much decentralized. So when you go to decentralization, so governance, security, and scalability are more expensive. So why is the cost access? So for example, Bitcoin, I mean, you have a lot of fee regarding maintaining and mining the coins. But when you reduce the decentralization and go to more centralized blockchain, so these are the issues. So single point of failure, monopoly, and economic rents. So most of the focus on to certain or limited number of miners or maintainers. So they can have a monopoly. They can basically use it as an economic rent. And since the limited number of maintainers, if some of them fail, then your whole of the network would suffer too much. Questions? Yes. So if there is no questions, please take a look at your model. I think I forgot to say that finally we found a TA. Let me just show his information. So if you open your syllabus, you can find the information of the TA, Mr. Sand Yousefi. So his office hours are on Thursday. If you have issues, you can just stop by his office or just make a Zoom call with him or email him. On Moodle, do you have a new assignment 5? You should talk about what's your guess about who's Satoshi Nakamoto. Some people think it could be even Elon Musk, but a lot of discussions in that. What I'm a little worried about your projects. So since there's not too much of a students in the class, I extend both of them to June 23rd. So by the last week of the class, please submit the first delivery and second delivery. Since just I think there's just 7 students in class and over Zoom, so if you want, you can submit the first one. You can email me, but your last time is the last week of the class. So last week. Please submit before I release your grade. Hopefully, you get good grades, but you should have you should submit something. What else? About the projects, so if few of you just stop by my office or email me, and I verified I accepted the topic. In case you want to talk with me, please either stop by my office, make a Zoom call, or email me. Sometimes I give you some suggestions about the projects. For example, if you remember in the first week, I said you can compare different proof methodologies like proof of work, proof of stake, proof of history. It could be one project, but generally speaking, any innovative any innovation in blockchain domain should be fine. If let's say today I talk about dApps and I show you some applications like healthcare insurance. These are good topics. So maybe you can say having a dApps related to healthcare on Ethereum blockchain seems interesting. You talk about you basically describe that application and then try to find some example of that and try basically justify and judge that application or something like that. So this could be another topic, but you are not limited to topics that I'm telling you. So you can, based on your interest, just try to find some innovative work in the blockchain technology. Reach me. If I accept it, you can submit it by the last week of the class. Questions? Okay, if there is no question, that's for tonight. Thank you very much. I'm sorry it was a little complicated. So in the plan for the next weeks, a little part of the blockchain is remain. I'm not sure if I cover it next week, but we have some interesting part coming on like how to do a little bit of buying, sending, receiving, maybe doing a little bit of Solana network, Solana blockchain, which I'm not good at technical details of Solana, but I know something. So maybe we can do some experiment over Solana. Again, thank you very much and have a great evening.